Hi guys, we're going to be working on synthetic division today. And synthetic division is very similar to polynomial long division, except we're going to be using synthetic division only for when we have divisors that are a linear factor. So in other words, it's just like x minus 4 or x plus 5. And if you don't know what I'm talking about, here's a look at our first example. The denominator is x minus 2, and notice it's x minus 2 to the first. Now, what we're going to do is, I don't know why the eraser is there. This is weird. Whatever. What we're going to do is we're going to go ahead and do synthetic division on this. And the first step I'm going to do is I'm going to take x minus 2, and I'm going to set that equal to 0. Solve it for x, I get x equals 2. The 2 is going to go in a little box. And then I'm going to take the coefficients of the numerator. So I'm going to take the coefficient of x to the fourth, which is 1. So again, this was for x to the fourth. I'm just going to work on my ways down all the way to x to the 0. X squared is going to be a negative 3. A positive 1 is going to go under here. And I didn't have anything under x cubed and x to the first, so I'm going to put a 0 here and a 0 there. And that's what I mean by don't forget the placeholder. Next, what we're going to do is we're going to bring down this 1, and here's how synthetic division works. I'm going to take the 2 and multiply it by 1, and whatever number I get, I'm going to put underneath the 0. Now the 0 and the 2, since it's a positive 2, I'm going to go on and add those together, and I get a positive 2. Next, I repeat this process. I'm going to take the 2 and multiply that by the 2 down here, and I get 4. And it's a positive 4. And a positive 4 and a minus 3 is going to get a positive 1. I'll repeat again. So I'm going to do positive 2 times positive 1, and that's going to be a positive 2. 0 and positive 2 is a positive 2. And I repeat the process one more time with a 2 times a positive 2 is going to be a positive 4. And then that's going to be a positive 5. Now here's what this actually does. When I take this x to the fourth, and this is the coolest part, minus 3x squared plus 1, and I divide it by x minus 2. Actually, this isn't going to be the coolest part because you're probably going to be mad that I didn't show you this before. So, I'm sorry. We're going to get 1, and now all these degrees, before it was x to the fourth, but since we divided by x, it's now going to be 1x cubed. So it's going to be a 1x cubed plus, because it's a positive 2, x squared plus x plus 2. And then finally, this is our remainder. And just like we did in the last section with the remainder, we'll put a plus 5 over the original divisor, which is x minus 2. The most interesting thing about this is that I could have done this method, x to the fourth minus 3x squared plus 1, and divided it by x minus 2, and I would have gotten the same thing. But this little algorithm here, though, takes care of that for me. And it's a little bit simpler, but the caveat is that you have to have a linear factor. If it was x squared minus 2, that's going to be a bit trickier to use. Our final answer for this one, just to make it clear, is in the box. That's terribly drawn. Now ignore the remainder theorem for just a second. It says find f of 2. So let's do it. F of 2 is equal to 2 to the fourth minus 3 times 2 squared plus 1. 2 to the fourth, you're welcome to use your calculator. I believe that's 16. Minus, I believe this is 12 plus 1. And if I do this math, I believe I get 5. And you're thinking, Why did you just, what are you doing, Mr. Lakin? And here's the interesting thing. Take a look at what we got. X to the fourth minus 3x squared plus 1 times x minus 2 was equal to x cubed plus 2x squared plus, I think it was plus a x plus 2 plus 5 over x minus 2. And f of 2 is equal to 5. If I look over here and I see something that seems like it's from aha, the 5s. So interestingly, if I do synthetic division, evaluates, I have an extra comma here, doing synthetic division evaluates the function at a specific x value. Now, you may not be a big of a nerd as I am, but I want to make sure you don't miss like how amazing this is. All along for the past few years, we've been telling you to just plug in numbers here, and then you have to plug these in the calculator, blah, blah, blah. But what you could actually do is plug them in this way. And I would be hard-pressed if you told me that, like, you can't say that's not cool. That is one of the coolest things that you've probably ever seen in your entire math class, ever. Here's how the remainder theorem works, and it was on the other page before, so let me bring it up here for a second, if I can find it. So the remainder theorem says that if a polynomial, some polynomial f of x, is divided by x minus k, the remainder is r, which is also f of k. So in other words, if I take some value that I think is that I want to divide into f of x, when I plug in that value, I'm going to get r. So let's see this actually work. Let's say that I have some function f of x, hold on, f of x, and let's say that it's equal to like x to the fourth minus 3x squared plus 2x minus 1. And let's say your teacher's like, I want you to find f of 2. And you're like, okay, well, I have to do 2 to the fourth minus 3 times 2 squared plus 3 times, too many numbers. So here's a different way you could do this. If you put the 2 here, and you bring the 1 down for x to the fourth, for x to the cubed, you bring a 0 down, for x squared, it's a negative 3, x, it's a positive 2, and x to the 0 is a negative 1. And you try this, bring down the 1, 2 times 1 is 2, 0 and a positive 2 is a positive 2, 2 times positive 2 is positive 4, that's going to be a positive 1, 2 times positive 1 is going to be another positive 2, and that's positive 4, and positive 8, and 7. Oh, f of 2 is 7. Come on, that's cool. Take a look at it this way. I'm going to bring this down a bit. Take a look at it this way. If I have some function, f of x, and I divide it by x minus k, we saw from the division algorithm that you get some quotient of x, which was basically all this stuff, plus some remainder times x divided by x minus k. That's how I would have rewritten this synthetic division. So I originally had x to the fourth minus etc., and then the answer would have been x cubed plus 2x squared plus, okay. I find it fascinating that if we do synthetic division, all I have to do is take the number at the end, and that's the value that I get for when I plug in 2 into the function. So allow me to just multiply everything by 2, both sides by x minus k rather. I think I said 2, I meant x minus k. And take a look at what happens here. The x minus k's cancel, so I'm left with f of x. And if I multiply this, I get q of x, the quotient, times x minus k, plus, here the x minus k's cancel, so I'm just left with r of x. But remember, r of x is always just going to be some number, so it's really just r. And if I plug in f of k, hold on. If I plug in f of k, I get q of x, q of k rather, q of k times k minus k plus r. K minus k is 0, and haha, f of k is equal to r, which means it works. If I ever want to plug in a value into a function, all I need to do is synthetic division, and the remainder is my answer. Here we have given that x plus 3 is a factor. Whoa. And if x plus 3 is a factor, that means that when I take my negative 3, by setting x plus 3 equals 0, I get x equals negative 3. If I take negative 3 and plug this into the polynomial using synthetic division, I should expect a 0, because that's what it says when I plug in k into the polynomial. I should get 0 out. So let's go and see if that's true. I'm going to get a 5 here. Multiply those together, I'll get a negative 15. That's going to be 3. That's going to be a negative 9. That's going to be negative 2. And it's like we predicted this from the long run. I do get a 0 out. This means that x plus 3 is a factor of x cubed plus 18x squared plus 7x minus 6. In fact, what we get is we get 5x squared plus 3x minus 2. 5x cubed plus 18x squared plus 7x minus 6 divided by x plus 3 equals that. Oh, cool, that's so awesome. Now, what they are asking for is to find all the zeros of f of x. And we know 1, 0. 1, 0 has to be x equals negative 3. They gave that to us. Now we need to find the zeros of this quadratic. And that's really what you did all last unit. So we could try to factor this, or we can do quadratic formula, or we could complete the square. Either way, it's your call. I'm going to see if I can factor. So I'll do a times c, which is 10. It looks like 5 and 2 could possibly work with a positive 5 and a minus 2. And if I rewrite this together, I'm going to get 5x squared plus 5x minus 2x minus 2. Let's do a factor by grouping. I'll get a 5x out of here. That's an x plus 1. I'm going to take a negative 2 out. That's also an x plus 1, which is exactly what I want. And look at this. I got it in factored form. That means x equals 2 over 5 and x equals negative 1. These are my 3 zeros of the polynomial that I had at the beginning. And I hope you enjoyed this. This was pretty fun for me. The next video is going to be optional, so feel free to watch it so that way you can get a little bit more help with this. Thank you.